And welcome back, everyone. Short break. So before we start, I would just like to say thank you again to Miguel and Nuno for being with us here today. I think you guys are starting to become residents of WDL as official commentators. But I guess that just goes to prove that you just have a lot of knowledge to share with us. So it's great. It's great that you accepted to be here with us today again. Well, since we have a lot of ground to cover this stage, because we have 4 challenges and we have the same amount of time to discuss, I would like to propose that we go maybe topic by topic this time, and we discuss a little bit. We see the questions that people have, and then we just take it from there, and we try to cover all the topics. Is that okay with you?
Yeah, of course.
Yeah, it's perfect. It's perfect.
Great. Okay, so let's start with traffic flow, which is the first challenge that we have. On the last stage, we proposed public transportation as a way indirectly to decrease traffic flow, I guess. But putting that option aside, what else do you know that we can do with data on this regard that it could solve traffic flow?
Shall I?
Whoever wants to go first.
Yes, go ahead, Miguel.
Okay, thank you, Nuno. So it's a pleasure to be back to the World Data League. I'm really anxious to see what are the proposals that we are going to be presented with trying to answer the challenge that we are releasing every 2 weeks. But regarding this today, the traffic, the road usage by cars and trucks and whatever, I would like just, before we go specifically to each one of the different challenges that were launched today, just to say one of the things about the relevance of the problem. So we know that the cities, they are responsible for 80% of the energy that is consumed worldwide. And this 80%, 30% are just from traffic, from mobility. And so there is a dimension, which is we have to improve the mobility within cities, because this is part of the necessary answer to climate emergency. So somehow we have to understand the traffic in the cities in order to improve the efficiency of the traffic, to decrease the number of vehicles, or else the time that those vehicles are on the traffic, on the infrastructure, because this is crucial to answer this challenge. And there is a number, just to have an idea, that the cars are parked 90% of the time. And furthermore, there is a thing called parasite traffic, because when the cars are in the city, 30% of the time, they are looking for a parking space. And so understanding how the traffic works, or the metabolism of the traffic, is crucial for the city, for the local authorities to take action at both the planning and operational level. So this is really important. And these 4 challenges that were released today, they are vital for the city authorities to improve how this can be done, either by giving a better experience to the person that is in the traffic, but on the other hand, which is probably the most important aspect, how can this be used to improve the city planning and to answer the climate emergency? There is another dimension that was not a question, I don't know, in 2019. With the pandemic, suddenly we saw, we just lived in cities almost without cars. And suddenly there was no noise, no air pollution. People were on the streets, using the public spaces, there was a huge increase on bicycle usage. And so by improving the efficiency of the mobility, namely the traffic with the cars and the trucks and the buses, we will be able to give benefits in terms of air quality, noise reduction, and have the public space used by people and not by cars, because we will be able to understand what are the problems, what are the needs, and at the planning level, also take action upon this. And I think that these four challenges are vital for cities to address this, and any idea, any insights that you can deliver in these four challenges are really, really interesting. Regarding traffic flow, the first challenge, as Miguel was asking us to address in the first moment, of course, this is highly relevant. We should be able to avoid cars staying too long at a certain point, stopped, and at the same time producing CO2. We should be able to understand, for instance, what is how can I take advantage? I'm able to count cars. So if I'm able to count cars, what can be explanatory variables of this phenomena? Okay, it's a weekday, it's a weekend, but also the weather. If there are bad weather conditions, should I change the traffic management? How these different things are related one with each other? Is it a school period? Is it an holiday period? All of these different external drivers will impact and will be able to explain the behavior that we are having on the counters of the city. So this is quite a very interesting challenge, and giving insights of what we can learn by counting the cars, and not only the cars, but also the direction that they are moving. It's really relevant. Nuno.
Well, hi everyone, and good afternoon, and thank you for having me here again. Well, basically, Miguel almost said it all, and I agree with him. But I would like, first of all, to share with you my opinion about this stage overall topic, traffic. Well, basically, I have to congratulate World Data League for this topic, because since the invention of automobiles, traffic is one of the major concerns in cities. And as you can see, all the challenges are very well chosen, because basically the first one, what do we want? We want solutions for a smarter traffic flow. We want less accidents, better parking, and more safety. And all of these relate and fit very well and are complementary. Well, about traffic flow, it is highly important, and I would even stress what Leonid said earlier. The outcome of this challenge should be not only an explainable model, so we don't want just a simple black box to predict traffic flow. No, more than an explainable model, the main goal, I should say, it should be to create a framework for decision-making for a city, to identify which is the best solution effectively to manage traffic flow. And this challenge is very important because, like Miguel was saying, there are several use cases that can benefit from an adequate traffic flow forecasting and prediction and management. For example, Miguel said it very well about all the implications in the environment. but also on citizen experience. Imagine that, for example, a city could provide a better experience, of course, managing traffic, could avoid precisely all the traffic flow bottlenecks. So forecasting and this challenge is quite important. Before turning back to Miguel again, I would like just to give you a few tips about this challenge, and a few tips more technical. So the keywords for this challenge should be, or the keyword should be causality. What can we identify as explanatory variables to predict, in fact, the traffic flow? How can we improve? Can we create, for example, a decision-making framework on this? And then I'm going to just leave you with a small teaser. Probably this is, from a technical perspective, this challenge, and for all of you that love data and data problems, this challenge can be particularly an excellent challenge. Why? Because you will have high frequency data. I guess you'll have a very granular data. So you will face probably two problems, because you will have to predict, on one hand, you will have to predict traffic and the flow, okay? And on the other hand, you will find lots of noise. So with high frequency data, probably you should also identify and try to identify what can explain volatility. Which are the factors that explain volatility in traffic? How can we provide a better experience, better traffic flow, avoid the bottlenecks, and basically provide for the city government or governance tools for traffic flow improvement?
Nuno, you mentioned. I'm going to pick up on this last sentence that you said to introduce a question, because one of the methodologies that we theoretically know, or maybe in practice even, that work to reduce the traffic flow or to reduce the bad type of traffic flow is the concept of super blocks or mega blocks, like what they have in. I'm remembering Barcelona as an example. If I'm not mistaken, I think it's when you have nine blocks all together in one, where you can just take your car in the major road outside. What's your opinion on how this concept actually works? What's your opinion on how it works in reducing the traffic flow? Do you think it works? Not really.
Well, it depends on a lot of factors. It depends. You cannot, for example, take a model and apply to any city. You'll have to take all the factors and all the characteristics of each city. For example, in this challenge, I would focus basically, because in all the challenges, we must have a very well-defined scope. Otherwise, we will easily get lost. But for a well-defined scope, it is something that, for example, for this particular city, probably all the groups could test with external data. But it depends on a lot of factors. For example, a specific solution that works in one city might not work in another city. For example, you cannot compare Madrid with Lisbon, for example. They are completely different, with a completely different city planning and structure. But for example, as you were mentioning, for example, in some of our cities, and I believe that in this challenge we have data from sensor data from Porto, right? Well, for example, in some micro places, at the street level, for example, one of the solutions, having an overall model for traffic flow forecasting, would be immediately to have smart traffic lighting systems, for example. it depends a lot on the level, on the characteristics of the city. One thing that works in one place might not work in another place, for example. So it's not that linear, I would say.
Can I also have,
Of course,
regarding
Miguel.
the reference to the super blocks, which was the strategy that Barcelona followed? The idea, it's a little bit trying to answer the both challenge that I referred in the beginning, because what they have done is that by creating these super blocks, within the super blocks, they were taking active measures to reduce the traffic and decrease the speed. And so they tried to, in this, each super block, the target was to return the public space to the citizen by removing the traffic on those super blocks. And so in order to do this, and given the reality that the traffic will stay in the city, we have to improve the efficiency of the remaining network of the, in order to guarantee that everything keeps on working. So this is one example of the relevance that insights about traffic can generate on operational terms. Just like Nuno said, maybe if we understand and we are able to predict traffic flow in near real time, we can link that to a smart traffic light system. But on the other hand, also, how can that feed the changes in the planning of the city and creating strategies like the super blocks? I have to just a note for the sake of fact checking to tell you that the Barcelona mayor, who was seen worldwide as a leader on smart cities, he lost the election. So I don't know if he was in fact efficient in providing a smart solution in the end of the day. So this is really crucial to take advantage of our data collection, processing, and information delivery capacities, so that we can have the ambition, but in the end to deliver the solution that is feasible and the answers the city and the citizens' needs.
That was a great comment you just made there. I guess, Miguel, I guess that the winner of WDL shouldn't expect to win an election just because they're the best ones at data-driven city.
Who knows? Who knows?
Yeah,
no,
knows?
But this just to say that, for instance, also in Spain, in Pontevedra, the mayor, just after being elected, he used a different approach. So just after being elected, he closed the car circulation in the center of the city, and he had a lot of problems for the first 1 or 2 years. But nowadays, he's seen as someone very inspireful, because he was right. So it's just a question of you have to plan it in order to succeed.
It's true. It's true. I want to pick up on the topic that both of you raised, which is both of you talked about speed and the speed of the cars and reducing the speed. We have a question about speed limits in cities, and the question is limiting a speed in the city to 30 kilometers an hour, or I guess any other lower number, helps or makes it worse? And I don't know if this is a linear answer, but what's your take on it?
It depends on the perspective, I guess, because you cannot look at space, you cannot look at the network just as simple as that, I would say. Because, well, you cannot forget that a city, it's a very complex structure, a very, very complex structure with several realities, with several centers, with several levels of demand for that space. So it's not that linear, but of course, in some places, and most for safety measures, and on one hand, on another hand, on traffic flow, I would say that it's more a political decision than anything else. Okay, so the key word is always balance. the key word is always balance between what is the equilibrium between the demand for that city, for that space, and all other variables like the environment and so on and so on. But it's not that linear.
I may add to this that if we are able to take advantage of data, and for instance, the second challenge, which is to understand accidents, traffic accidents in the city, then maybe we could take active measures to change by design the infrastructure so we can reduce the speed of the cars in the places where we have problems. Because one of the greatest advantage that I see that is created by this data science or data-driven approach to understand the city problems is that in fact we can almost do like a acupuncture in the city. So we will be able to identify the problem, exactly where it happens, why it happens, when it happens, and then we can take measures not only to answer it when it happens, but also to change the city in order to prevent it from happening in the future. So I think this is the idea. The speed limit in the city, in fact, is a tricky answer because it will treat everything like the same, and we know that everything in reality is different.
Okay, I think that's a good hint because we know that we have some speed data on the data sets, and I guess that's a good hint for the participants. If you're going to use the speed data, you might also want to know where this speed is actually occurring. So maybe the coordinates, knowing on a map where exactly the vehicle was, so that you take into consideration the infrastructure of the whole road system.
And probably if you look for further data sources, you will find information regarding the width of the street of the road, if there are sidewalks, the signals, vertical and or horizontal signals in road intersections. All of that can and for instance, now I know this can make it a little bit more complex. But if you think a little bit regarding accidents, one of the things that impacts accidents is the position of the sun. Because sometimes when you are driving at a certain time of the day and in certain streets, you don't see because you are just, I don't know how to say it in English, so blinded. You will be ofuscado by the sun.
Yeah, you're blinded. You're blinded by the sun.
Blinded by the sun, okay.
Yeah.
No, that's a great hint actually, because we also have weather data. I don't know how much you can get from the angle of the sun, man, but if that would be really interesting to have all of this defined. And we know that these are not all the variables, but at least I mean this is the point.
You can keep on making it more complicated.
Yes,
now exactly. We can have the 3D model of the city with the buildings, and then some of the buildings will create a shadow in the streets, so the sun will not impact. So
but that's extremely relevant. We kind of moved on to the topic of traffic accidents, and I would like to stay there as well, and ask both of you, can you give one or two use cases where you saw the potential of data science in kind of anticipating or predicting traffic accidents?
Well, Miguel already anticipated one, of course, because all these challenges are complementary. Basically, one of the beautiful things that data gives you is precisely this capability to be a sniper, to know exactly where you should act, and not only to, for example, reduce speed limits in large places and in large segments of the city. So you can target precisely where you should act and why. Well, about accidents. Well, one of the main missions that any city government should have is, of course, to provide a better living for citizens. Well, we are talking about living. We are talking about reducing accidents and be proactive. One of the things, and the key word for this challenge, I believe it is proactivity. So to have, if in fact, the identification of all the motives, I wouldn't say probably the angle of the sun, the daytime, it would make too complex, but all the groups are free to get that info because it's open, of course. It will they will have to probably refresh some trigonometry and so on because of the angle of the Earth to the Sun. But the main point is what determines, in fact, what are the advanced indicators to predict accidents. And once again, one of the things that you should, or the groups should look for is some sort of generalization. Why? Again, also in this challenge, to provide for the people that rule and govern the city a framework so they can decide, so they can identify and map and apply to any other city, just to identify, okay, with this model, I can predict accidents. I can plan, for example, how I'm going to occur to these accidents. I can prevent and provide another experience or try to avoid in many ways. Okay, so but the key point I would say is precisely, again, to identify the causes and to be proactive.
I can, if I have the opportunity, just to share a real world case.
Of course, Miguel, take it.
We at Nova Cidade Urban Analytics Lab, last year we had a project with the Lisbon City Hall, where we had access to accidents in the city of Lisbon in the last years, traffic accidents that required the intervention of the fire department, which is responsible to send the emergencies vehicles to the accident location. And the challenge was, we have several fire squads scattered all over the city. And we want to guarantee that if an accident happens, we must get there in less than 5 minutes. And what we have done, we have applied the 3 types of analytics. So descriptive analytics, try to describe using the historical data what were the patterns. Then predictive analytics, we built a model with machine learning that was able to predict where tomorrow there was the probability of occurrence of an accident in the city. And thirdly, prescriptive analytics, because if we were able to understand the phenomena and predict where probably there will be accidents tomorrow, then we made an analysis to find out if the service areas of each fire squad was able to serve in less than 5 minutes the location where we predicted that tomorrow there will be accidents. And this is a real world example of a practical application of this kind of problems. So if I understand the accidents, if I can predict them, this can have in reality a huge impact in the city and how the city hall can manage the whole urban space.
Okay, that's a great insight on. It's good to know that that we already have other projects also on that on this area of traffic accidents happening. Besides
Miguel, just one thing, and let me tell you that you have in the mentors of the World Data League 2 of the people that were involved in that project. So Marcel Mota and Pedro Sarmento, they were directly involved in that specific problem, so you can reach them.
That's great. Okay, awesome, great hint. Besides traffic accidents, what other safety hazards should we take into consideration when thinking about the general safety of all stakeholders in the city? So not only people that are in their cars, but also people that are using the city, cyclists, pedestrians. What other safety hazards are there, and how do you think that data can help in detecting this?
Well, basically, you can apply this to any type of mean of transportation. Of course, you can apply. You can have safety hazards, for example, not only for pedestrians, of course. Just taking cars apart, not only for pedestrians, but also for bike users, buses, and several other kinds of accidents that might happen on a road network, because we are always talking about a road network. And here, like Miguel, when we were talking about traffic flow, a very important information and very important data is precisely the kind of structure that the road network has. The signs, the junctions and intersections, the number of lanes, the directions, the speed limits, for example, the typical the size. So all the characteristics of the road network, because mainly some types of road networks are more propense, for example, for accidents. For example, visibility, also the visibility, for example, and there is external information that the groups might get, for example, to look at the visibility of traffic signs, to look at the visibility, for example, at all the junctions. For example, imagine that someone is driving or a pedestrian is passing by in a small piece of road segment without much visibility, for example. There are lots of external data that can improve and augment all the possible candidates to explain any types of accidents. But typically, I would focus mainly on these kinds of safety hazards, concerning, of course, everything that is related with road networks and all the traffic, because we cannot forget that the main topic of this stage is traffic. So I would focus on these kinds of accidents.
Okay. If I may add something, if we shall I say, if we make this outgrow from specific car and traffic accidents, and we think about atropelamentos, I think in English it's hit. People
when you run over
problems with bicycles. If we think a little bit, these are different problems. And just to why am I saying this? When we run the project with the Lisbon City Hall, with the fire department, one of the problems was exactly that. Different accidents have different types of accidents, have different characteristics and different explanatory variables. And so we should not treat them as they are the same thing. So a run over or a bicycle accident or a car collision, they have completely different behaviors and completely different explanatory variables. So this is, and this is critical because maybe a run over happens where we have schools or where we have public spaces or I don't know, a public transport central hub. And so these are things that probably they are not related with car collisions, but they are relevant to explain runovers and bicycle accidents. Maybe we should bring into the network the cycle infrastructure. So each one of these different type of accidents will need a different explanatory model to generate the insights that could be relevant.
It's great insight. Great insight, Miguel. I have you mentioned again the project that you had with the data from Lisbon, and I have a direct question about that. Actually, I'll just squeeze it in here. The question goes, Miguel, the model for predicting the accidents in Lisbon, is it still in use nowadays? And if yes, do you have any metrics regarding the impact?
That is the present challenge. Okay, so Lisbon has a city intelligence platform where they manage the city in operational terms, and so the ambition was: can we build proactive information that will change also not only the capability of the city to answer what happened, but give them the opportunity to predict what may happen and support the city, the different departments, either internally or externally, like the fire departments or the police or whatever. And so in this moment, what we are working with them is to try to see how we can embed these predictive models in the city platform. So this is a running project. It's not finished yet. So, but that is what is happening now.
And have you thought already about any metrics regarding the impact? Have you thought about how to measure the impact of this?
I think that there is a direct measure that we will must to take into consideration, which is the confidence of the prediction model, right? So are we going to have accidents where we are predicting that they will happen? And of course, the second metric will be the capability of the fire department to reach the accident location in less than 5 minutes. So this is two obvious metrics, but this is a still future work. Results to achieve.
No, but those are great examples, especially the second one. I think it really portrays how people that are working on this area should go beyond just the model performance. You should really understand how your model impacts the metrics that are already being used, regardless of if you used AI or you didn't. There will always be a societal metric, let's call it like that, that will be impacted, or it should be.
I think that that is probably the most relevant insight. I should not say that because this is being said by Miguel, and me and Nuno, we are the ones that should giving the insights. But this idea from Miguel is probably the most relevant aspect. You should find a problem that your model is going to solve and to contribute for the city and the society and the people quality of life. Okay, so this is the end of the game. Unless if you can build the best model, but if you don't have a purpose for it, it's okay. It's nice to have.
Yeah, no, we keep insisting on that, but it makes complete sense, of course. Nuno, I gave a direct question to Miguel, and I'll give you one as well. This is a question from the audience. You mentioned several times the need for a framework in different contexts, the need for a framework. And there are people who asked, is that framework, are you talking about just the machine learning model, statistical analysis, along with some insights drawn from it? Or is it something bigger?
Think of it, well, you can address or think of a model in the strict way, okay, like we are understanding it, or you can think of it as part of a broader and larger decision model. Your analytical model, your machine learning model, any model that you define, for example, to forecast, it's just a piece, a valuable piece from a broader, when I say about a framework, what do you think a decision maker needs? What is the outcome that he gets for example, a simple, accurate forecast? And if he runs in another city, will that model work? So you have to think of it strategically. Your model will prescribe not only the forecasts, but it should prescribe, if possible, also the variables and probably to design a decision framework. When I say a decision framework is, for example, and I was thinking while you were talking about the next challenge, the irregular parking, for example. Why do we have irregular parking? And for irregular parking, I was also thinking of a simple decision framework. Well, probably we might have irregular parking because, well, the citizens are bandits. Okay, imagine. So we want to go after them. Or probably in some other cases, we might have irregular parking because we have more demand for parking than we are offering, than the city is offering. And if you imagine, for example, a city in a grid, it's quite easy to, like Miguel was saying, to first describe and do descriptive analytics to understand where do we have irregular parking, yes or no, and then to see if that is consistent over time. Being a proxy, for example, to identify if people really want to park irregularly, systematically, or not. And this will provide us, for example, a location decision framework just to identify, for example, where are the places, first, that we have less offer than demand for parking, for example. We might have to adjust that. Then, on the other hand, also, not only these gaps between demand and offer for parking, but also on the behavior side of citizens to identify which is the and where is happening voluntary irregular parking. So we can, in fact, educate or define policies for that specific area or for that specific population. So when we are talking about a city and having decisions based on data, it is important to have it always. And when we are modeling, and like all of us that we love data and love modeling, when we are modeling, we cannot forget that we always have at least two levels of decisions to make. Our model should address both operational decisions and also more strategical decisions. So imagine, and I'm just mixing all the challenges and your question, but for example, for irregular parking, the first thing and the most important thing to know is where is it happening and why? And is it deliberate or not by that population? Is it a problem from the population, or is it a problem that the city is not providing the adequate tools to address that demand? For example, with a better public transportation network and integrated, with more parking places available, with smarter parking places and parking solutions. So at these two levels, I would say that the most important thing in data is, and in data science, is decisions. And so when we are talking about a city, decisions have several levels, but we have to manage the city. And that's why I'm always talking about, don't forget the strategic level. Try to provide the framework for strategical decisions.
Okay. We kind of started talking about parking, and but that's great. That's great. That's our last topic, regardless. Miguel, do you want to mention something about parking using data?
Yes, of course. If you allow me, regarding irregular parking. So I think that, given I just gave the example of the accidents and the answer capacity of the fire department. Irregular parking, when we look at for the first time, we think, but that's not really interesting. But if we think a little bit, irregular parking needs a very quick answer. So when we think about our daily lives, when irregular parking occurs in certain conditions, it's really impactful of the city life. I don't know, in Lisbon with the trams, that is a huge problem. For instance, people that parks close to a garage access, people that parks in a space which is reserved for handicapped people, and on the second row. To understand this phenomena is critical once again in the two dimensions. First, at operational level, so provide a quick answer when the problem occurs, because each minute there is a problem of irregular parking, we are impacting negatively the traffic flow of the city. And on the second side, which is the planning, the strategic dimension that Nuno was mentioning, what can we do when we found out that there is a specific hotspot in the city where we have constant irregular parking problems? What should we do in order to prevent that from happening? So I think it's once again, it's an example on how we have a very well-defined scope of the problem. We have traffic, we have the road infrastructure, and we have a specific problem, irregular parking. What can we do, taking advantage of data science, to improve the operational answer and trying to predict where it will happen next? And also, how can we give insights that explain the reasons of that problem in order to, by design, preventing it from happening in the future?
That's great, Miguel. We have 4 minutes left, and I just want to ask another question about parking that I think your answers might give some additional insights to the participants. Nuno mentioned the necessity of finding the where and the why in terms of irregular parking. I guess the where, we all think about the smart parking systems, for example, and maybe that's a easier problem to solve. I wanted to ask you both about the why. How can we find out the why? Why are people parking irregularly? And again, we just have 4 minutes. I hate to break it to you, but it's the time that we have. Go ahead.
Well, I'm going to well, I can tell you, Miguel, that it's something that the groups should answer. That is a question for them. But I would separate this. I would start with this very, very simple thought. Well, why do people irregularly park? Because they are aware of it and they want to, or they aren't in fact aware of it, that they are irregularly parking. So probably what data can provide us is the way, and we have to be creative, like Leonid said on the first slides. Please be creative. Data science is all about creativity, to identify ways to see if in some place irregular parking is systematic. For example, if in one place, because we don't have, surely we don't have individual data, user data, we have geographical data, and in which places do you find that irregular parking is systematic or occasional? In one place, if it is occasional, probably so it's not a voluntary or as serious matter as that. So you have to be creative. You have to identify ways to measure what is unmeasured. This is the beauty of creativity and data science, okay? But it's a question that, in my opinion, it's the key question to make. If you want to give an overview and to describe all the irregular parking from a macro perspective of one city, and then to propose solutions. And solutions are not only go after the citizens and go to increase the city revenues. No, it's probably to, in some places, to educate that population, to provide them with better solutions, better parking solutions. And in some cases, yes, it's to fight and coercively act. So you have different actions, different strategies for different locations with different problems. So basically, that's what you should, or the groups should try to focus. Which different strategies for which different places that are caused by different characteristics.
Miguel, we have 30 seconds. I'll let you have these last 30 seconds. You can talk about parking or whatever you want. Go ahead.
I just want to say, enjoy the ride. Okay, so and don't get caught in a traffic jam on the way.
Unless you already have the prediction model.
Yes. You know, unless you already know how to get out of it.
Yes. No. It's that's really important. It's the most important thing in data science. Have fun, basically.
That's the best hint. Okay, we're almost running out of time.
We're out of time. The stage has started, guys.
Awesome. Leon, do you want to wrap this up? I'll let you have the final word if you want.
All right, perfect. Thank you so much. Well, thank you everyone for joining us here at the Roundtable. Miguel, thank you so much for facilitating it. Sorry, and of course my dog wants to have the last seconds of fame.
Murphy's Law.
Yeah. The stage is open. The challenges are there. As soon as we go out of this session, also all the data will be there accessible for you. You can start looking into it. If you have any questions, feel free to ask them on Discord. There is already, I think, some mentors there. And we also invited all the topic entities there. One really quick final note is that if you don't have your answer right away, I mean, because all the topic entities and all the mentors and so on are also working, doing their daily life, just wait a bit, and I'm sure that during those 24 hours, someone will get back to you. I think that's it. Enjoy. We have 4 challenges to choose from, and stay tuned for more news on Discord. And thank you, everybody. Bye-bye.
Bye-bye. Stay safe.
Bye.